Dear class, welcome back to the application of learning analytics in learning management systems. I'm glad that we have already proceeded to the final week of this course. I do appreciate your participation, persistence, and engagement which have made this course very well. Since we don't meet face-to-face for this week, I would like to briefly wrap up the course by reviewing what we have learned throughout the semester. And the topic of this lecture video today is using learner data in technology environments. Some reminders. The lecture slide was derived from Professor Roger Azevedo, who is the psychology faculty at North Carolina State University. I had a chance to listen to his review comments about the development and issue of learning analytics in 2016 AERA, and he kindly emailed me his slides for educational purposes. I further adapted and revised it for this course. During our class sessions, I mentioned that the future breakthrough about the study of learning will foreseeably be answered by either cognitive neuroscientists or educational data miners. We have learned that learning analytics researchers are looking for innovative ways to understand learning behaviors. With the rapid advancement of technology systems, understanding and using learner data in technology environments become viable. We can now use learning technologies for studying the complex nature of learning, understanding problem solving and collaboration, and probing sense making, and so on and so forth. Frankly, it is still a complicated and difficult job, but at least you get a roadmap of how learning analytics can be accomplished. Presently, learning researchers approach the realm of learning by designing specific features of the learning technologies. Therefore, they can articulate, verify, and improve theories of cognition, instruction, and learning. Technology systems like learning management systems offer an ideal platform of collecting necessary data for model verifications. Moreover, instead of context and outcome data, we also found that learning analytics today focuses on learning process data. New research designs and methods are thriving in order to answer questions and concerning learning process. In the lab sessions, we can clearly see that qualitative and quantitative changes of student learning can be tracked and analyzed. Not too surprisingly, learning technologies have supported learning analytics to measure, collect, analyze, and foster learning in specific tasks and domains. However, learning analytics is still young, and analysts are challenged by conceptual and theoretical issues. Let's take a look what are the future to-do list if you are interested in becoming one of the learning analysts. First of all, there exist challenges in understanding learner data. After reviewing literature and best practices of learning analytics, we found that learning analytics deals with a variety of issues such as context, dynamics, patterns of learning and participation, affordance, mediating processes between human-machine interactions, learning trajectories, change over time, and so on. However, the data, as long as log files we can derive from learning management systems, is still limited. Like I said in the class, we need to work hard to define constructs, mechanisms, and processes based on the data which is available to us. To step further, we will be able to use those well-defined constructs, mechanisms, and processes to model cognitive, metacognitive, affective, motivational, social, collaboration, co-construction, as well as other learning processes. Secondly, we can include the discussion of external mechanisms that will affect learning processes or outcomes, like adaptive scaffolding by technology learning environment, tutor, teacher, and peer interactions. Besides, we need to better understand the role of peers, teachers, agents, tools, affordance, and so on in the technology environments. We know that the roles of peers as well as other agents have high impact on the acquisition, retention, use, and transfer of learners and teachers' knowledge and skills. We also need to observe the qualitative and quantitative changes in domain knowledge and skills, 21st century skills, teachers' practice, metacognitive monitoring, motivational processes, etc. Thirdly, we need to carefully consider how we use the learner data extracted from LMSs. Even though we make effort in moving beyond gross-level behaviors and self-report data, what do those log data mean? It has been challenging but exciting for learning analysts to describe, explain, predict, and until we can build features to support, foster, enhance, and facilitate the quality of learning. Additionally, we need to consider possibilities of scaling up when we collect rich trace data in various of types like log files, eye tracking, the scores, dialogue systems, facial expressions of emotions, etc. So, what we have done well and what remain area of improvement. In his 2015 work, Azevedo created a two-way table showing which tool and data is appropriately applied in a given learning issue. Green cells means the tool is well developed and is a good fit in answering the particular learning question. Areas in red or yellow tell you that the method or tool is unlikely to help you answer the question. In the left column, you see Azevedo list a bunch of methods and tools which he categorized in 4 baskets: process, product, self-report, and knowledge construction data. The top horizontal row lists 4 different types of learning questions from cognition to motivation. For example, we're not likely to figure out learner motivations using learning management system log files or quiz results, but self-report surveys will help us capture that information. You can pause here to dig a little bit deeper before moving on to the next slide. In the previous table, Azevedo mapped where we are and how we are doing in the field of learning analytics. For the future of conducting learning analytics, Azevedo proposed 8 topics that will focus on process-oriented detection, measurement, and analytical methods. His suggestion includes 1. Examine the sequence and duration of temporal unfolding processes. 2. Temporally align and analyze multimodal and multi-channel data. 3. Study the temporal dynamics and synchronicity for individual learners and between individuals and across individuals. 4. Discover profiling, clustering, and other exploratory approaches. 5. Develop qualitative and quantitative data analytics methods. 6. Develop granularity, temporality, time sampling inferences. 7. Explore data mining, data analytics, and machine learning techniques. 8. Realizing adaptive scaffolding for students. I believe we have experienced a few ways of doing analytics, such as using social mining and data mining tools. Finally, Azevedo proposed a 4th stage of how we understand and use data in technology environments. In the beginning, what we can think of as an instructional technologist, was to design learning experience with a technology environment. In the next stage, we start to realize that trace data is useful and is collected. Next, we expect learning technologies to adjust and react to students in real time based on the on-the-fly analytics to offer students adaptive learning activities. Finally, data analytics and learning experience are concerted together. That can be cool, isn't it? Well, it comes to the end of the course. Thank you for taking it. As my students, you always have my lifetime warranty about the course. So, please feel free to email me questions and comments, as well as sharing thoughts and ideas in terms of learning analytics. By the way, please submit your final paper on time, and I wish you a pleasant long vacation. See you around!